So let's go ahead and sketch the graph of the polynomial, and we're going to sketch the graph by stating the end behavior, the maximum number of turning points, finding the zeros and their multiplicity, and stating whether each zero crosses or touches in our graph. So we're going to be working with the polynomial f of x equals x plus 1 times x plus 2 times x plus 3 squared. So we start by stating the end behavior. So your end behavior comes from your leading coefficient. In this case, our leading coefficient is going to be basically your a, right? So you look at your polynomial here. There's no number there, but it's understood to be a 1. So our leading coefficient is 1. Then we have to state our degree. So in this case, we have an x that's going to get multiplied by another x. So we have a power of 1. It's going to get multiplied by another power of 1. And this is going to get multiplied by another x, but this x is going to get squared, so it's another power of 2. When you multiply x's, you go ahead and add their powers. So 1 plus 1 plus 2, you can see we end up with a degree of 4. These two pieces of information are going to help us understand where's our graph going. So we have a leading coefficient of 1. So now we have to make the conclusion, is this a positive or negative number? We're dealing with a positive number. So now you look at your degree. Are we dealing with an even or odd number? We're dealing with an even power. So because we have positive and we have an even power, we know our end behavior is both going to go up. So to the right and to the left, they're both going to go up. Now your turning points. The maximum number of turning point comes from taking your degree and subtracting 1. So our degree in this case is 4. If we subtract 1, we end up with 3. So the maximum turning points we can have in our sketch is going to be 3. So now we need to identify our zeros. So remember, zeros is just another word for your x-intercepts. So in order to find your zeros, you take your function and you set it equal to 0. So we're going to take x plus 1 times x plus 2 times x plus 3 squared, and we're going to set it equal to 0. Luckily, this polynomial is already factored for us, so we don't have to factor it. So if it's already factored for us, the way we solve it is we simply take each of our factors and we set it equal to 0. So we end up with x equals negative 1, x equals negative 2, and x equals negative 3. So we're going to have a 0 at the point negative 1 comma 0, negative 2 comma 0, and negative 3 comma 0. So we have 3 different times where we're going to be either crossing or touching our x-intercept. So the next part is to state whether it touches or crosses. That comes from your multiplicity. So we have to talk about the multiplicity of each of our zeros. The multiplicity simply means how many times is the factor occurring from where the 0 comes from. So this solution came from this factor, so you look at the factor. How many times was the factor occurring? In this case, the factor only happened once, so we say it has a multiplicity of 1. Now you move on to the next one. This 0 came from this factor. This factor of x plus 2 is only happening once, so we say it has a multiplicity of 1. Same here. This solution came from this factor. If you look at the factor, this factor, because it's being squared, the factor is happening twice, so it has a multiplicity of 2. Then you have to identify, it's your multiplicity even or odd number. In this case, we're dealing with an odd number. So odd multiplicities are those multiplicities that are going to cross. 1 is also odd, so that means this 0 is also going to cross. Here we're dealing with an even multiplicity, so even multiplicities only touch and turn around. So we know when we're graphing this ones, these are going to cross, this one is only going to touch and turn around. So that's finding your x-intercepts. So we also need to find our y-intercept. And your y-intercept is the same thing. In this case, now the one that is 0 is your x. So we're letting x be 0. So when we go back to our function, everywhere we see x, we have to plug in 0. So we have 0, and take a look at your function. 0 plus 1, 0 plus 2, 0 plus 3 squared. So we end up with 1 times 2 times 9. So that's how we get 18. So I know my y-intercept, our x is 0 and our y is 18. Now you're ready to graph your polynomial function. So when you're graphing your polynomial function, I'm going to go ahead and write all the pieces of information we know. We know our x-intercepts are going to be the points. We had -1, 0, and we know we're going to cross, -2, 0, and we know we're going to cross, and we had -3, 0, and we're going to only touch. So we go into our x and y axis. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have the point -1, 0, and I'm going to make a note to remind myself that I need to cross. At -2, 0, I have to make myself a note also that it's going to cross, and at -3, 0, I have to make a note that it's going to simply touch. Our end behavior, we know they were both going to go up. So this is how you do this one here. We're missing this one. So let's just pretend we went all the way up to 18. So this, let's say, for some reason, we went all the way up to 18. So here's our y-intercept. So we know our end behaviors are both going to go up. So that means on this, to the right-hand side, we have to go up, and to the left-hand side, we also have to go up. So now we just have to connect our pieces of information. So we go down to our 0, and the 0 is only going to touch. So it basically just bounces back up. So we're going to bounce back up, and then that's one turning point. So remember, we had a total of a maximum of 3 turning points. So here's our first turning point. We're going to have to come back down and cross this. So here's my second turning point. We have to come back down and cross. And we have to cross one more time. So here's our third turning point. So we have 1, 2, 3 turning points. And now we're going to come back up, cross our y axis, and keep going forever. So notice that if you went all the way more up and more down, it's okay. We're just trying to sketch it. So this is the idea of graphing your polynomial function. If we wanted to know exactly how high, how down it goes, we will have to create our x and f of x table to fill in our gaps. So in this case, this is -2, -3, so we can look at -2.5. From here, we go from -1 to -2, so we will look at -1.5. Find the corresponding y values, plug them in, and know exactly how far and up it's going.